So check out what just showed up from Bilstein. 4 boxes. And you could probably guess what's inside these because, well, Bilstein builds shock absorbers. And they're one of the major sponsors of our giveaway Gladiator. So we're gonna be installing these on the giveaway Gladiator when the lift kit shows up. Now what's so cool about these shock absorbers? I gotta see these being built. That's right, Bilstein invited me down to one of their factories, the one down in Poway, California. That's just outside of San Diego. And that's where they build the majority of their high performance off-road shock absorbers. They invited me down to do a tour. I got to walk through the building, see their machining, see their assembly, see these shocks being put together and even put on the test dyno and test it. The next day, I got to hang out with their hosts from the Bilstein podcast, Mike and Shane. They're both longtime Bilstein employees, both of them over 20 years there. And we got to talk about all kinds of fun stuff. So if you like behind the scenes videos, factory tours, things like that, well, you're gonna love the rest of this video. If that kind of stuff bores you, we'll skip to the very end. We're gonna open these boxes and show you what's inside. All right, we just landed in San Diego, headed for Poway. Tomorrow, we visit the Bilstein factory. And check this out. Dollar rental car hooked us up. Number 421, and that's a Jeep Wrangler. Oh, gotta love the new dash. All right, we're out of the rental car check, and it's on to Poway. All right, good morning, everyone. We are up and rolling towards the Bilstein factory.
Starting route to Bilstein. Proceed to Stowe Drive, then take the first left.
Here we are, Bilstein. So we're in Poway, California at the Bilstein factory. And this is where they build those 8100 shocks that we'll be putting on the Mojito Gladiator we're giving away. All right, here we go. It's the first stop here at the Bilstein factory, and I've got Mike and a whole crew with you, Mike, and we are headed into the machining area.
Yes, this is our on-site machine shop. We have a lot of 3D machining capabilities in here, and we're gonna show you some of the parts being made real-time in action.
All right, let's go.
Here we go. All right, so as you can see, lots of machines, lots of metal. A lot of what we're making here is for the 8112 products and also the Blackhawk products, the UTV products. Usually the machines go through 3, 4, 5, 6, 7 different steps to make the different parts cut, cut this, cut that, so you can kind of see the different stages of it. So one machine might make a few cuts to make that size, and then cut it down to that different size. But this just really gives us quick time to market. It's just amazing the capability of these machines, how much time they save us, right? I mean, you look at the quality of these parts, they're just absolutely beautiful. And that's a good shot of, this is what it was before it went in, this is what it was with maps. Op 1, Op 2, Op 3. So it goes from that to that, it goes from that to that.
And it's all done right here in the USA.
So this is our QC lab, by the way. And we use this lab to check our parts and parts we get from outside vendors as well. So anytime a part comes in from outside, it gets checked. We even check our own parts in this same lab with same quality standards on everything.
Here's one example of this is a UTV mount cap. Spray this white powder on it, kind of gets the contours of all the part. And we put it in this 3D scanner and it stitches everything together on this computer. We can upload a file and it'll compare the actual to the CAD file and highlight any differences or give it a green check if it's all good to go. So every part gets the same treatment no matter what it is.
It has to be perfect, or obviously it's not going to operate properly once it gets in the shock. And we'll see that stuff all come together next door and let you put your hands on it and put it together and throw it on the dyno and make it work. So this is a planar contour tracer, so there's a needle on it. So we can put this part like that, and this needle, it's very precision needle, will come down and drag across that contour. And we can check things like snap ring grooves, threads, the surface roughness of a part, of the sealing surface. So this tool really highlights the important, like I said, sealing surfaces and threads.
It'll even check sealing surface roughness.
Yeah.
That's pretty sensitive then.
Yeah.
So it reads 2D surfaces. So if we put this piston, it'll look down, it'll measure the overall diameter, inner diameter, the diameter of all those holes, as well as the concentricity of all the holes between each other. We have chamfers, angles. You can put it on here on a bunch of different angles, and it'll take care of everything. Here's a good example. These holes are 6 millimeters in diameter, and there's this check valve that seals this surface of this piston, and then there's a valve stack on top of that. If there's any impurities on the surface, this valve is not going to seal, and the performance of the DSA, this is a dual speed, high and low speed adjuster, it's going to be completely out of spec. So this is very important. There's a lot of labor that goes in here, so we don't want to be building these up, putting them on a shock, then putting them on our dyno, and finding it out. Then we have to take it all apart, put something else on there, do it all again.
Yeah, by the time you get to that point, you've got some serious labor tied up in it.
Yeah. So anything from tubes, top mount supports, to rod ends, to adjusters, anything and everything we can do at this facility.
So nice to have that kind of machining capabilities. All right, here we are. This is where the assembly takes place. This is the Bilstein assembly line. So this is just one of the factories that Bilstein has here in America. We have the one in Poway, California. That's where we're at today. Then you have Hamilton, Ohio.
Hamilton, Ohio, and then Mooresville, North Carolina.
Mooresville, North Carolina. So which shocks are built here in Poway?
So here in Poway, we build 8100s, 8112s, 8125s, the 9200 and 9300 race and UTV products as well. Everything is hand assembled. There's not a ton of automation, but we really focus on quality. Then in Hamilton, Ohio, we build our 5100s, 5160s, 6112s. Then in Mooresville, that's going to be our race headquarters for Circle Track. Some of the 7100s are built there as well. Here at this facility, we do between 10 and 15,000 units a year, where in Hamilton, Ohio, it's about close to 1 million units per year. So it's definitely a different level of assembly and manufacturing, but we're lucky we get to kind of do the cool stuff here at this facility.
But you guys are doing 10 to 15,000 shocks a year here. They're all, that's hand assembled.
Hand assembled, yeah.
And there's only 365 days in a year. So that's a lot of shocks.
So first at this stage, this is our general sub-assembly area. Mount caps and all of our adjuster assemblies are assembled here. This is one good example of an 8112 mount cap. This is for a Tacoma and a 4Runner. This highlights our internal jounce cutoff or hydraulic bump stop. So it's a 2-stage telescoping piston. So first stage here. So in that last couple inches of travel, shock travel that is, your piston's gonna collapse and collide with this and collapse that in the first stage, and then into the second stage, it's gonna do the same thing all the way down. So this improves your damping performance by sometimes double or even triple what it is in the regular performance zone. So it's gonna be very, very comfortable in general driving and through the chatter and off-road. But then when you hit that big rut or in the whoops or a G out, this is really gonna save you and you're not gonna feel it.
And these are then the 7100 you said?
These are 8112s.
8112s. Okay.
8112s. 8112s and our 9300 UTVs use the same technology.
Oh, that's pretty awesome.
Yep. So this next assembly, this is a dual speed adjuster manifold. So DSA is what we call it. This provides both high and low speed compression adjustment. So the low speed is going to be the gold knob here. It has 20 clicks, 2 full rotations, and the high speed is 10 clicks, 1 full rotation. This is used on a lot of our 8100s. It's used on 8112s, as well as our UTV products. The engineers, they'll set it somewhere in the middle of the adjustment range out of the box. This gives the closest to factory feel for the customer, but the customer then has the option to go much firmer or much softer, depending on preference or the terrain they're going over. These adjustments we'll show you on the dyno later. It provides 150% in some cases of adjustment range. So they're just, you can do anything. If you're adding weight to the front bumper, you're putting a different spring on there, you know, towing, there's all sorts of different things that this thing will handle.
That's spectacular.
Give you a quick overview of this machine. So this machine, this is a bore honer. So this, all of our bypass shocks go into this machine. So when you have a bypass shock, bypass body tube, there's all these ports and tubes welded to the side of that body. Welding introduces a lot of heat to that tube, and there's warping that happens. It's not much, but it's enough that a piston will not fit through that tube. So we'll throw it on this machine. This machine runs through the bore of that tube for a couple of minutes and gets it completely perfectly round to a very, very tight tolerance where we can throw that piston into the shock and it's going to perform exactly like the specification.
And that gets back to making the best product you can absolutely make.
Absolutely. So I'm going to walk you through briefly kind of what's going on in this area. Then we'll jump into actually building a shock for the giveaway Jeep. We have 4 or 5 major steps during assembly. We have a reservoir assembly table here. We have a body assembly table here, a valving and rod assembly, and finally oil and gas as that last table. So grab a couple of examples here. So this is a 4Runner 8112 reservoir assembly. This is an example of what is going on at this stage of production. We push a dividing piston into the tube. We attach all the end caps to the tube. We attach the hose. There's very specific clockings that these products need to be clocked at. So for example, this one's 45 degrees off the end of the reservoir. Can't be this way, it can't be this way, otherwise that is not going to fit in the vehicle, especially those 4Runners with very tight wheel wells.
Super application specific on the reservoir clocking, just because the mounting brackets are so precise on the frame. Everything lines up, the hose doesn't bind, there's no travel problems when the suspension expands and compresses, so that's super important on the clocking.
Absolutely.
They actually make a left and a right and they're clocked differently.
Absolutely. Not only are we clocking it to the reservoir, we're clocking this fitting to this fitting.
Yep, yep.
So these fittings are clocked in accordance to each other as well. To a tolerance of plus or minus 2 degrees.
Plus or minus 2 degrees.
Yeah.
Yep. And he makes all the tooling here to position those hoses and the fittings and everything so that when the guys go to put it together, they drop it in, they look at the drawing, line everything up, tighten it down.
Tighten it down, exactly. Yeah. This machine here, his nickname is Ivan, named after Ivan Stewart, famous off-road racer. We kind of gave him the Toyota livery as well.
Gave it the Iron Man Stewart.
Exactly.
Yeah.
Exactly. So it's a tube washing robot. So this is one of the processes that we decided to automate a couple of years ago. This is a dirty job. I mean, you can see how dirty the whole machine and robot assembly is at this moment. But it'll grab a tube off this cart, it'll bring it into the machine, it'll wash the bore of the tube, it'll rinse the bore, it'll dry it, and then drop it on the perspective table. So this robot supports 4 different assembly stations, this reservoir and this body assembly, and then on the other side as well. So it's programmed, it'll ask you a few questions when you start the machine, what table you're working on, and it'll drop the tube, it'll roll towards the operator. We'll give you a demo of that when we start building that Jeep shock as well.
Okay.
This body assembly station, so this is where the mount cap and the body get married up. Sometimes the reservoir gets married up to the body at the station as well. And everything's one dry package at this point. This next stage of assembly, this is valving and rod assembly. So these are a majority of our valving shims that go in the shock. There are millions of different combinations that we will throw in the shock. And per the engineering spec, we will pick the valving out, check it once, check it twice, throw it on the piston rod assembly, and then marry everything up in this final oil gas fill assembly table down here.
One thing that's really cool about this valving assembly process is that not only did those boards survive many iterations of the company, they've been around for probably 50 years,
But the other thing is each disc, as they pull it off the board, they could get mixed up and things on the board. So they have to measure each disc, the thickness, the diameter, if it has any other characteristics. They check all that. They lay it out on this towel in a specific order. And then another person comes by and rechecks all that before it gets built into the piston. So 2 people manually measure all of those parts. Could be what? 25, 30 discs at some point?
On average, it's about 20, 25 discs in an 8100. In an 8112, there's up to 50 discs. So there's
2 people handling 50 discs just to make sure that they're in the right position, the right dimension, nothing got mixed up.
All for one shock.
All for one shock.
Yeah, so that's pretty amazing. And those discs are very special. It's not just a washer you buy at Home Depot. It's special spring steel that's made for us in Germany. It's proprietary. It's been the building block of our shocks for 70 years. We have competitors trying to buy these discs from us because they're so special. So yeah, this is the secret sauce of Bilstein.
Absolutely.
This station right here.
Absolutely. Yeah. And then after it's checked twice here, everything is married up in oil and gas, and then we throw it on our shock dyno to make sure that we did in fact assemble it to engineering specifications.
We're talking every single one shock.
All 10,000 of them a year.
And all 10 to 15,000 a year.
That's
Now,
correct.
we need to qualify that again. 8112 DSA Plus. How many adjustments do we have on that shock?
We have over 200 adjustments on that shock.
And what does the guy on the dyno have to do before he lets that shock go in the box?
He checks it fully open and fully closed.
Checks every click compared to spec. So I don't know that they run 200 times for each shock, but the possibility is that shock could be dynoed 200 different times to check each click on the dyno before it goes into the box.
Absolutely.
It's pretty intensive.
That sounds like a very interesting job. Just running shocks on the dyno, one click after another, up to 200 different clicks. Anybody want a job like that? Gotta talk to these guys.
Yeah.
This might be a good shock to get some B-roll of. This is a service order that's coming in. Here's an example of that valve stack that's laid out in a specific combination.
Now this is a shock that's come in for service, so you guys are doing full service on this.
That's correct. We'll
That's
change.
what shock oil looks like when it comes out of the shock. It's a little beat up.
This came off a Gladiator with a bypass and coilover setup in the front. This specific shock was leaking out of one of the seals after 3 years of service, or running it on some of the harshest trails we have around here. He said he took it to Moab multiple times, and finally one of the seals gave out. So we're here to.
One of the seal heads, or do we know where the leak was coming from?
We're not quite sure where it's coming from. He might have mentioned it was coming from the hose fitting, but once oil leaves the shock, it gets everywhere and it's hard to kind of isolate it.
Coated, yeah.
Yep. But we'll get this guy back up and running by the end of the day.
How's it going?
Hi,
Kyler.
I'm Tim.
Nice to meet you.
Good to meet you, Kyler.
So Kyler's been with us about 4 years.
Yeah.
4 years total. He does everything from shock tuning, on the production floor building shocks, and then of course service as well. He's out there supporting our racers at different events, champ races, King of the Hammers, all over the place.
Yeah.
Okay. And you're gonna show us how to build an 8100.
Yep. Yeah, we got the Gladiator shocks. Actually, they're right here in this bin. So, pulled all the parts yesterday for them. Kind of shows when we pick the parts how it works. They all come in the production order. Lays out all the part numbers, the quantity, the locations, and everything. Basically, what goes into the whole shock. Then we pick it. Everything's divided up. Put the part numbers into it. Just make it super easy if something's damaged or wrong or whatever it is. We have the part number right there to look it up and to find it out. So yeah. So this is this is the whole shock right here. So it's pretty cool.
So I don't know if we were that clear at the very beginning of this video, but the reason we're here in Poway, California at the Bilstein factory is we're gonna be building those shocks that are going on the giveaway Jeep.
So first, before the parts get here, it goes through quality. So quality checks all the parts and they have to do initial pass and everything.
Okay.
But still, like, once they're packaged again in a warehouse, we get all the parts. We still do a whole check through the parts again. So like here, the tubes, we'll get the tube, we'll inspect it for chips, damage, if it's bent at all or anything like that. And if we have any questions, our quality lady's right out there and we can talk to her and ask her questions. So yeah, we'll go through a full check through with all the parts first, and make sure it's all good, and then from there we'll just start building the shock.
It's like Christmas, man.
Right? It's like opening presents.
Unwrapping all this good stuff, getting ready to put it together. It's my favorite part of any project.
I think, like Riley said, once we, in the production line, when we have all the shocks opened up and the body tubes and reservoir tubes, we'll put them in Ivan, and they'll clean them for us, and while they're doing that, we can do reservoir assembly.
Start pulling different parts.
Yep.
Maybe building some hoses.
So the robot doing the monotonous job saves time while you do something else.
Oh yeah.
Plus you don't get covered in greasy, crazy shotgun.
These tubes are painted with a very durable paint as well as zinc plated under there, just to make sure we're completely protected against corrosion. You can see some of that zinc, there's a little bit of zinc on the inside of the tube as well. So we put it on a robot, it ball hones the inside of that and it gets all that zinc completely out, makes it a very smooth and fresh surface.
The actual tube by itself, mounting parts, seal kits, the rod assembly. So I already previously opened them, but like here's the piston rod. So it shows all the lengths and the dimensions. Make sure we have the right ones. And here's kind of the table to go off of. Another one is the actual rod assembly. It shows you where it goes, the seal pack, the wiper cap, the valving, all that. It's nice with all these drawings too, it shows all the part numbers. So if you don't know, you can just find parts right there. Just super, super nice. Yeah, so all like the main details of the shock are on the main drawing. So we have how much to fill the shock oil, or how much to fill the shock up to, the PSI, the dyno force of the rod extension. We have our dyno results of what we want of the forces, all the drawing information, what application it's on, sticker information. Pretty much everything is all in the main drawing. And like Riley was saying, we have sometimes 2 to 3 people checking them and make sure everything passes every single time. And if something's not, when we dyno test it, you'll see there's a graph and you'll easily see when something's off. So you open it up and you'll find there's a missing shim or something like that, and you can fix it, which is great.
One shim difference
Oh, yeah.
makes a huge difference
Yeah.
on that graph.
Yeah, exactly. So every single shock that goes through, they're 100% matched. They have to pass the dyno to be able to pass through. So it's really neat to see. It helps us a lot with ensuring our products are the best they can be at all times.
Well, and that's got to be one of the fun things or nice things about working for Bilstein. They're so into making everything so perfect. It gives you some pride in what you do and who you work for.
Oh yeah, it's great. I mean, you go out to these, even when I go out to these races and stuff, and people talk about our race shocks or even their shocks they've had on their F-150 for 150,000 miles, like they're guaranteed to last. That's what everyone knows. Like they're 100,000 mile shocks. That's what everyone says. So yeah, it's great. It's cool to go out there and look at these shocks and look like they came off the production floor after 50,000 miles. And yeah, so I just kind of just lay out all the parts first, make sure I have everything, kind of check everything, make sure nothing's damaged or missing. And I don't know if Riley showed, this is our digressive piston. This is what's in most of our 8100s, 8125s, 6112, 51, well, the 5100 line is smaller, but these are our digressive piston that we use in them. So yeah, this is where we'll start with cleaning the tubes. So I'll clean them over here to demonstrate. So then, yeah, we'll just throw it in the line, put up to 20 bodies in there. Kind of just simple press play, ask simple questions. If it's a body tube, yes. What line you're working on. And if it's a steel, because we have 2 different body tubes. We got steel tubes and then we have aluminum tubes. And with aluminum tubes, we don't use the honing. We just use the nylon brush. So with these, the steel ones, we use the honing and the brush. Press yes, and it'll kind of just do its thing. and then it'll just keep running through until it doesn't read anymore. And you pause it, then we'll just start the same process again for the reservoir. Just like that.
Oh yeah, after the hone and the
A lot more cleaner.
It's like a mirror.
Wow.
Might be able to see better from this one. We have a fixture that this guy goes into. Kind of just pops in. And then the thread of this, put 540, just a little dabble of 542. I'm gonna just tighten this down to hand tight. Right about there. And then this is the dividing piston, which we put a Viton O-ring over. This guy goes with it. And it always has a certain orientation of how these go. Normally the smaller concave side is always on the oil side. But if we have a shock with a DSA in it, since there's valving and everything that sits higher, it'll actually go the other way, so it clears the piston, the nut, and all that. And this is the end of our reservoir. That'll pop on. And then we can start the assembly of our reservoir. Biggest friend in shock is grease. Grease saves seals, makes it a lot easier to assemble a shock. A little bit of oil around the sides of it and on the O-ring to help it slide in. Paint a little bit around. A little bit on the cap. Kind of pop it in. So this will be the oil side. So then next we'll grease up the O-ring. This will just tap in. Nice little tool that when we install the snap ring on, it doesn't sit perfectly, kind of push it in, use this to rotate it. Sits in fully, and then you can pull up on it so it's seated correctly. And then kind of just clean it up, make sure all the oil's off of it. And then we have a debris ring, which will sit in the crevice in here to help keep debris or anything else out of there.
Oh yeah, those little rings will get a bunch of gunk in them and they're hard to get back out. That's really nice.
Yep. And then since for gas and oil we'll do use a vacuum, I like to make sure the dividing piston's all the way down, just like so. Again, just kind of wipe it off. And then until labeling, that's about it for the reservoir assembly. And then next, I'll do the body assembly, which is the body tube. Here's the cap, the hose goes into, the kind of same process, just throw an O-ring on it, throw a bit grease around the O-ring, and then the body tube right above the threads in here.
Yep.
Like about ½ an inch, we'll just put a nice just coating of grease right around there just to help it slide in across the mount cap. And then on the drawing right here has our specs again. So we'll tighten the body tube to 100 Newton meters and a 271 Loctite. Half a thing of 271. And we'll just slide. And once it's seated down, make sure it's clean again. Every single different tube we torque on has a different sleeve collar that's called for, and we have a chart, actually it's right here, of the different types of like body tubes we have. So we have like smooth plated zinc, we have Evo Gray, which is this one, threaded zinc, just like that body tube, and each one has a different sleeve collar. So this one calls for this one for the Evo Grays. Slide it over. So, and that's the installation of the body until we do some labels on it. Put this to the side. But then next we'll do the valving and the rod assembly. So here's the piston rod. here's the threaded side for the rod end, and then the other side's for the valving and the piston. So everything we have here goes into, we got the seal pack, the main piston, the wiper cap, the traveler, and we got the washers that go with it. With these, we have a certain tool that fits on the rod end to help slide over our seal packs so it doesn't damage the O-rings or anything inside. The bullet tool's on, so this helps greatly just slide over. And then there's a wiper cap and the seal that goes with it. Pops in like so. Slide the traveler on. And then next, we will go over to the valving table. So we'll pull up the production order. And then in the PO should have our valve stack layout. And then when I do it, I like to highlight anything that's not a disc, just so it makes it easier to keep track of what I'm doing. So I'll highlight the washers, the bypass shims, the check spring. I have this little table, so when we pick our shims, it kind of stays in line and everything, keeps everything organized. So on here, it says our kind of like width and how thick they are. This one, our washer shim is 37.5 by 3. 3. And kind of just we'll start from the bottom, work our way up. So next will be 1850. And then what's nice is if on our board we ever run out of shims, we have a big sheet here that shows the location of all of our shims. And then all the cabinets over there, all the blue ones, have all of our shims in them. So it shows the location, we can go there, grab a handful of more, and then stock up the boards again, which is really nice. It's like here, so we're out. So it'll show the location, and then we can open the drawer, and it has all of the shims in a certain size in here. So I'm looking for a 3625, which would be these guys right here. So I'll take a handful and bring them back. And then for our bypasses, it'll say, same thing, it'll say the width, how thick they are, and then how many ports are in the bypass, if you're not sure. So this one has 2. It says it right here. So these are one of our check springs that go on the compression side. And these just go with our digressive piston. So this plate sits on top of it, and it sits here, and there's some shims that push it up. So the first initial hit gives it that push down of flow, but then it hits the rest of the valve stack to stiffen it up. So it creates a first initial bit of oil flow, but then the rest of the valving catches it. So it's not just harshness right off the bat or rough. So you have that plush and really nice feel.
Like a temporary bleed almost.
Yeah, exactly.
And a fancy bleed shim
is
what it is.
Again, it's velocity sensitive to a different level from the rest of the stack. So it's pretty cool.
That's really cool.
And then these have to be seated correctly. So when we put it together, put a little bit of oil on it so it sticks there. Because this, if you assemble it and you don't, it could get moved a little bit, and then you'll see in the dyno result it won't activate. So yeah, it sits like that, just like so. So when it moves, it's kind of hard to see, but it'll fall down, allowing the initial oil.
And you do all these shims dry.
Yep. That check spring, and then with the piston for these, we'll grab a little bit of oil, put it right where it's going to seat, put our shim, and just put a little bit more, just so it doesn't move or anything. It'll seat properly and we don't have to worry about it. So we'll install that guy, and then just continue. And then once we put the washer on, there's a bit of a gap here. And our rule is when we install this nut, the threads we want sticking out, we don't want it to be any less than 0.1 millimeters or any more than 1.5 millimeters. And the nut is 7.5. So we'll just measure the length of it. So that's 12.5, and then subtract 7.5. So we got 5 millimeters to play with, give or take. So then we'll add some spacers to space it out, and just keep checking it. If we don't space it out, where the nut bombs out, it won't tighten to the piston. So it'll be a lot of play.
more room on the
super
tenon.
loose. Yeah, it'll be super loose.
It isn't to protect more of the piston rod running into another part internally, or just because we don't want the piston to be loose on the tenon?
Just for what I've seen is the piston to be loose. Because when you see it loose, you'll see it move up and down. And I've actually seen like shims like disintegrate because they're flexing so much. And then our nuts already come with, they have Loctite already set on them. Run it down, bottoms out. And then we'll put this in the vise. And this is an 18 millimeter rod. We have anything from 18, a 22, a 25.4, and 28. And we have all different fixtures for it. So and this just holds the rod and allows us to be able to torque the rod end on and to torque the nut. So the rod end will get 271 as well, just a little bit on the threads. Turn that on, and then this is torqued to 50 Newton meters. And then our nut is torqued to 50 as well. So our digressive pistons, since they're steel, they are torqued to 50. Our aluminum pistons, our linear pistons, they're torqued to 28 Newton meters. Perfect. Just put a little bit in. Kind of just make sure it's even. Grab a rag. And then that's the piston rod assembly done. That's what goes in the shock. That's what makes the shock do the thing. So we got our hose here so we can finish the reservoir assembly. So there's a longer side for the banjo fitting and a shorter side. The drawing will say which side goes where. The longer fitting goes on the reservoir side. And that's the reservoir done, and we'll get into the labeling right now of it. And then on here it has a whole bunch of different part numbers, so it's a multi-use tool. And then on the drawing it shows where our gap label is going to be, and that's what this part represents. So right here shows our gap label. Looks like it has our gap and everything, and if we compare it to our drawing, kind of how it would look. Got it straight down, the gap angled. Looks good. And then next would be the same thing for our body. And just like so.
Yeah.
It's our body tube. Every shock we put out has a QR code. There is a label that comes out, the QR code that has the part number and production order, so any customer can scan it and can pull up all the information of the shock. We'll put it on just like so, and that's the final assembly of the body. And next we just put everything together now. When we vacuum the shocks, we'll put 300 milliliters of oil in, and then we'll vacuum it out about 2 to 3 times, make sure all the air is out of it. So we'll throw this in. And then we'll grab our air line. This is our vacuum, and it has a preset time on it to 6 seconds. It'll go to 25 PSI. We'll throw it on top. And then when you're vacuuming, especially with the DSAs, you'll feel the air bubbles coming out. You can feel it coming through the shock. So that's kind of your indicator of when to keep vacuuming or not. If you don't feel any more air bubbles, you're good. But sometimes, like those DSAs, especially with the 70 millimeter shocks, you'll have to do it like 4 times to make sure all the air is out of them. It definitely affects the shock's performance as well as oil volume too, because sometimes you can put a lot more oil in it than you have in there.
Just like
and you've seen,
radiator on
yeah,
the car.
yeah, because you have that JCO, the RCO, and the DSA that all could trap air into. So it's very vital you get it all out. So I put 300 in it and it requires 1066. So I put 766. And then so we're gonna put the rest of the oil in, so the oil levels can be really high. And then we have a pusher that will push down the dividing piston.
But now that there's no air in there, it'll be perfect.
Yeah,
Yep.
and we can set it to where we want it to be.
Perfect.
That's what I'm doing right now.
That's a proprietary
So we have-
shock oil.
So we have a little bit of shock oil left, but the oil volume is really high. So to give us a little more room, we have this pusher tool that basically has a cutoff valving on the compression with an open on the rebound. So when we push it in, it'll let us push the dividing piston down. So we'll just push it down a little bit. Probably about there is good.
Yep, and it's just push that piston.
So then we could dump the rest of our oil in. And then now we'll set the dividing piston up to where it needs to be. So the drawing calls it to be 118 millimeters. So this is our pusher tool. So this will push into the end until it bottoms out into where it's gonna set. So yeah, once it's set, you can see we're not bottomed out. And then when we press this down, you can see the oil level come back up into the shock. So I'll press it down and set it. The oil came up to where it needs to be. To verify to make sure that our shock level is correct and everything, I like to measure from the seal pack down to the bottom of the piston, about a 40 millimeter gap. And I like to make sure that's the space that we have in the shock is at 40, just so it'll take out all the air because we don't want any air in the shock. So if there's a little room, which is a tiny bit, just like so.
Just to top it off.
Just top it off, make sure. And then next we'll install our piston, which we're gonna put a little bit of grease on our O-ring. To eliminate the air, since there's still an air gap, we'll push down the rod all the way until the bottom or until we see oil start coming out, and that's how we know there's no more air in it. And then we'll slowly move the rod down, because if we push it too fast, it'll move the dividing piston and create that air gap again. So we
Get that oil to flow up through
Yep.
the...
Then we have a pusher tool that we'll just slide over. See, once we're getting close, you can start to see oil come around the edges.
Just starting to come up.
So we'll go a little bit more. I just want to make sure all the air is out till the oil overflows. Just like so, it's coming down the sides over here. So that to me, no more air. So we'll just press it down and I'll pull up a little bit on it just so we have a little bit of room to work with. We'll install the reservoir end on. And as you hit it on, a little bit of air gets trapped in, so hit it out. Just so we can see the snap ring groove. Wipe it. Put the snap ring on. Just like so. And then next we'll pressurize the shock. And before we put the gauge on and set it up to 200 PSI, I believe it is, yeah, 200, we like to surge the shock to make sure all the snap rings and everything's seated so it's not going to shoot off into the atmosphere. So we'll just hit a quick little, make sure everything's seated. Actually, it sounds like so. That's another thing too, when we pressurize our shock, we like to see if anything's leaking. Maybe it was just set it. But sometimes we'll have we have a water gauge right here, and we'll spray it around the Schrader, the top one, and the O-ring on the side. So if it's leaking, we'll be able to see it. Because again, if it's leaking, we don't see it and everything, it will, on the dyno, it'll show super low gas force. So then we do this, we don't see any air bubbles, and we're good. So we have this pressurized tool. It's pretty cool. It actually has our DSA knobs on it. So yeah, we'll just screw it on. The blue knob. And we'll...
And that you have nitrogen on.
Yep.
It's just,
Yep.
What else would you expect at a shock place?
Right, and then we have a regulator right there to adjust the pressure we want. So then I'll open the Schrader. So it says we have 150 around right now. So we need 200. And for it to equalize fully in the shock, we'll get to like 200, maybe a little bit more than 200, and then we'll let it sit there for a minute to make sure it fully equalizes. Because if you just go 200 right now and cut it, it's really only like 195 maybe in it. So we'll let it sit for a couple seconds. So that should be good. So close off the valve, close off it, and then this little guy releases the pressure. So it helps it to turn off easy. Now shock's pressurized. And then now the ST14, when I pressurized it, moved that seal pack up. So now hopefully it got most of that oil out. So I'll wipe it off. And then I'll blow it out too. Got a debris ring right here that we'll install. Same thing, just tap it on. Yellow cap first. Then we have another secondary Schrader cap that goes on top. And then once this is done with dyno, we'll do the final assembly. We'll torque it down and clean up the shock fully. And then that's our shock right there. After gas and oil and everything. So next we'll turn into dyno, which we'll put in the dyno. So that was the warm up, and then it'll run through different speeds. We have 0.05, 0.13, 0.26, and then 0.52 meters per second. Once it's done testing, so you can see the digressive piston right here. That's what makes it digressive. It ramps up at first and it kind of mellows out. So yeah, this is our graph. This will compare and show all the data. And then this will show all of our dyno results. So whatever the forces and stuff we need out of the test, it shows everything right here, and we can compare if it passes, if something's wrong. We're able to see it in the graph or in the data, and then we can check it out if it's from the valving, if it's gas force, if it's oil, whatever the issue may be. We'll be able to see it right here.
Now it's got the proper offset bushing for a Gladiator. Well, there's one down. They've got 3 more to go. But we've got lots of other stuff to see, so we're gonna let them actually get back to work, because you know, the time he took to build this one shock, he probably could have already built 20 or 30. All right, it's day 2 of Bilstein, and today we're gonna be doing something a little different. Today, we're gonna be sitting in on the Bilstein weekly podcast. And I've never done a podcast in person before, so it'll be new to me. Now, this is something they do on their YouTube channel, so you'll be able to check it out, and we'll have a link on there when it does come available. So sit back, enjoy it. All right, I told you this morning we're gonna be doing a podcast with Bilstein, and I'm here with our hosts, Mike and Shane. Mike and Shane, say hi.
Hello.
Now, this is something they do on their YouTube channel, and you guys do this weekly, don't you?
We do record weekly and we release episodes monthly.
Okay. So you can go to their YouTube channel, check out their podcast, check this one out. Hopefully I do a good job, and we'll bring you some highlights later.
Came down for a purpose, and I think the folks would be really interested in hearing about what that purpose was.
We've been lucky enough to work with Bilstein for years, and it's been a really good relationship. You've helped us with past, not only do we sell the product, but you've also helped us with some of our past promotions, including our giveaway Jeeps. And we're doing that again this year. We're giving away 2 Jeeps, a 2025 Wrangler and a 2025 Gladiator. And you guys are the official shock sponsor for the Gladiator build.
Lucky us.
Excellent.
Yeah.
So I was talking with Bilstein Brian.
Yep.
And the idea kind of started down in Moab. We were sitting there having barbecue, and it's like, what can we do to really amp this giveaway up, at least the sponsorship part of Bilstein? And
Shane and I are both enthusiasts, and we, when we're building our rigs, we go to the internet to look for information. And so I told you when you walked in, I'm stumbling through installing an S-Pod on one of my projects, and I just happened to Google how to install an S-Pod, and up comes the video from your channel, you at Northridge putting an S-Pod on one of the giveaway vehicles. And just so everybody understands, I was confused before I watched the video, and after the video, I'm like, okay, it totally makes sense now. And now I don't feel challenged anymore. I just need to take the time to get it done. But so this is no nonsense. These are really good technical videos that you're putting out. So kudos to you. I felt really way more comfortable with the install after watching the video.
All right, well, we're back at the rental car return, and it's been a good Jeep. But of course, aren't they all? So we're headed for the airport, headed back to Seattle, and we hopefully will see those Bilstein shocks in just a couple days. All right, we're back here in the studio. What did you think about the tour of the Bilstein factory? Was that fun? Would you like to see more factory tours like that? Well, drop that down in the comment section below. Now, let's stop stalling and show you what came in these Bilstein boxes. Oh, hey, look, that's kind of cool. No packing peanuts, packing cardboard boxes. Instructions. So there we have it. Ooh, the Bilstein 8100s. Now this is the rear, it's got a piggyback reservoir on it. And then our front, that has a remote reservoir on it. Now for off-road driving, if you spend a lot of time, especially going fast on bumpy roads, that's where reservoirs really come in handy. This reservoir holds extra oil in there, and so it's gonna help keep the shock cooler over time. Now both these shocks, front and rear, are monotube design, and they have a 60mm bore. That's over 2 inches. So that allows a really large piston inside there. And that larger piston will give you better control, or will give the shock better control over your suspension in smoothing out those bumps. Now, if you're familiar with Bilstein shocks, you might notice these look a little different, and that's because they have the new updated coating on them. This is the Bilstein Evo Gray. It's a matte gray finish. Of course, it's corrosion resistant, it looks good, and heck, it even feels good. Now, these shocks are gonna be going on that giveaway Gladiator. We have a 3.5-inch lift coming from rock crawler suspension. Now for lift range on these shocks, we went with the Bilstein 3-inch to 4.5-inch lift range. And that gives us a shock that's 31.5 inches fully extended and 19 inches collapsed. And that's gonna be perfect for that rock crawler lift. So now we just gotta get everything installed. So stay tuned for upcoming videos on this giveaway Gladiator, and you're gonna see more of these 8100s. And I can't wait to get them off-road and see how these things feel. Thanks for watching today. We'll see you again soon.